If you use AI to code, you might be giving up more than you realize. A recent study looked at what AI actually does to your skills, and the results are a real wake-up call. In this video, I'll break down exactly what they found and how you can still use AI without falling into the trap. Anthropic ran a study on 52 software engineers. They were asked to learn a Python library they had never learned before. They were split into two groups. Both groups were assigned two coding tasks to help them learn the library. The first had access to the library's documentation, but no AI allowed. The second additionally had direct access to GPT-4o. And both groups were told two important things. First, to finish as quickly as possible. And two, they would have to take a quiz immediately after. And the results are eye-opening. On the quiz, the AI group got an average of around 50% compared to the non-AI group's 67% average. That's a 17% difference. To put that in perspective, if this were a college course, that would be the difference between a solid B+ and barely passing. And here's why this matters. There was also a pattern in the types of questions they got wrong. A core software engineering skill, debugging. They struggled with questions related to debugging, which makes sense. Debugging is the ultimate test of your mental model. When you write the code by hand, you're building that mental model line by line. It's like the difference between cooking a meal and ordering takeout. If the takeout tastes weird, you don't really know why. If you cooked it, you know exactly what you put in, and you'll know how to fix it. Okay, but the group that used AI at least wrote the code much faster, right? Turns out, overall, the AI group was not statistically faster. Wait, what? AI writes code in seconds. Humans type at what, 40 words per minute? The researchers analyzed the screen recordings and found something interesting. A large portion of the participants spent a surprising amount of time stuck negotiating with the AI. You type a prompt, it gives you something slightly wrong. You say, no, not that. Do this instead. It fixes one thing and then breaks another. You end up in this passive-aggressive argument with a chatbot. And while you're having that argument, you're not looking at the code. You're not thinking about the logic. All right, so is there a way to have your cake and eat it too? Actually, yes. Some engineers in the AI group finished relatively quickly and still did well on the quiz. Same tool, different outcome. It turns out how you use the AI matters. We'll break down 6 distinct AI usage patterns. And stick around to the end if you'd like to see which ones you should adopt. The worst performers fell into 3 patterns. The first one is the most obvious, the AI delegator. Basically the copy-paster. Write this code for me. Copy, paste, submit. They treated AI like a vending machine. They learned almost nothing. The second one is similar. The researchers called this progressive reliance. This group actually tried to learn. At first, they tried writing the code themselves, but as soon as things got hard, they lost confidence and switched to full delegation. The third one is a bit more insidious, the iterative debugger. This is the person playing whack-a-mole with the error. They write some code, it breaks. Copy-paste the entire error into AI saying, fix this. AI gives a fix. They paste the fix, but that breaks somewhere else. They paste the next error. They aren't trying to understand the cause of the error at all. They just want the scary red text to go away. This way of using AI was both the slowest and the worst for learning. So avoid this at all costs. All right, let's look at the winners. These people used the same AI with totally different results. The highest scorers used a strategy called generation, then comprehension. After their code was generated, they didn't immediately use the output. They paused, read through the code, and then, and this is the key, they asked follow-up questions about it. Why this pattern? Why this structure? Could you explain the logic behind this? They intentionally added friction. The second successful group used something called hybrid code explanation. They would ask for snippets of code, but they would also ask for the explanations, both in the same prompt. This took longer to read, but that reading helped build their mental models. The final successful group barely asked for any code at all. They just asked conceptual questions. They used the AI like a search engine or a documentation guide, but they did the final implementation work themselves. It takes a lot of discipline to have an AI that can do the work and force it to talk to you instead. All right, so here's the final takeaway. When you use AI to code, especially on a new task that you're not familiar with, ask it to teach you, not just do it for you. We're actually seeing the emergence of features specifically designed for this. Things like Claude Code Learning or ChatGPT Study Mode. They're trying to reintroduce that beneficial friction. And if you find yourself in that iterative debugging loop, pasting errors, accepting fixes, pasting more errors, just stop. Take your hands off the keyboard. That's the signal you've stopped thinking and started flailing. Now, if you're curious on what it actually takes to become a great software engineer, check out this next video. I'm Kos, and I'll see you in the next one.